Alright, let's go. Number 12. The Big Freeze. The universe does not end with an explosion. It ends with a whisper, stretched out over a trillion years. Right now, the universe is expanding. Every galaxy that is not gravitationally bound to us is moving away, and that expansion is accelerating. Dark energy, the mysterious force that makes up roughly 68% of everything that exists, is pushing space apart faster and faster, and there is no known mechanism that will ever make it stop. The consequence plays out over timescales so vast that the word vast loses meaning. In about 100 billion years, every galaxy outside our local group will have receded beyond the cosmic horizon. Their light will no longer reach us. Any civilization that arises after that point will look up at the night sky and see only the stars of their own merged galaxy. They will have no evidence that other galaxies ever existed. Cosmology, as a science, will become impossible, not because it is wrong, but because the evidence will have physically left the observable universe. In a few trillion years, star formation ends. The hydrogen gas needed to build new stars will be exhausted, locked up in dead remnants, and scattered too thin to ever collapse again. The last stars will be small, dim red dwarfs, and they will burn for a few trillion more years, and then they will go out too. What remains is a universe of black holes, cold stellar corpses, and photons stretched to wavelengths longer than galaxies. Temperatures approach absolute zero. Nothing moves, nothing changes. The universe does not die. It simply stops being able to do anything at all, a permanent frozen maximum of entropy, in which time continues, but nothing is left to mark it. Number 11. The Big Rip. What if dark energy does not stay constant? What if it gets stronger, until it tears apart space itself? The Big Freeze assumes that dark energy has a constant density, that as the universe expands, dark energy stays the same amount per volume of space. But the data does not quite require that. The equation of state of dark energy, a parameter physicists call W, is measured to be very close to -1, but the error bars still allow it to be slightly more negative than that. If W is less than -1, dark energy does not just persist, it grows. This version of dark energy is called phantom energy, and it produces the most violent death the universe could undergo. The timeline is brutal. As phantom energy strengthens, it first overcomes the gravitational bonds between galaxy clusters, pulling them apart. Then it overcomes the gravity holding individual galaxies together, and they dissolve. Then solar systems are stripped, planets torn from their stars. In the final hour, Earth itself is pulled apart by the expansion of space. In the final fraction of a second, the expansion becomes strong enough to overcome the electromagnetic force holding atoms together, and then the strong nuclear force holding atomic nuclei together, and every particle in existence is ripped away from every other particle at the same instant. The Big Rip ends not in emptiness, but in a singularity, infinite expansion rate, infinite energy density, every point in space separated from every other point by infinite distance. The universe does not fade, it is dismembered. Current measurements suggest W is very close to -1, and slightly on the phantom side. The error bars are shrinking every year. Whether the universe ends in a freeze or a rip may be decided by a decimal point we have not yet measured precisely enough to read. Number 10. The Big Crunch. The original death of the universe, everything collapsing back into a single point, in a fire hotter than the Big Bang. For most of the 20th century, this was considered the most likely ending. The universe exploded outward in the Big Bang, but gravity pulls everything back. If there is enough matter, the expansion slows, stops, and reverses. Galaxies begin approaching each other. The sky, over billions of years, fills with incoming light. The cosmic microwave background, currently a few degrees above absolute zero, begins to warm. In the final era of the Big Crunch, the sky itself becomes hot. Starlight from every direction converges. The universe's temperature rises past the surface temperature of stars, then past their cores. Atoms are stripped apart. Matter collapses into plasma, then into a state of density and energy beyond anything since the first moments of creation. Everything, every star, every galaxy, every atom that ever formed, is compressed back into a single point. The discovery of accelerating expansion in 1998 made the Big Crunch seem unlikely. Dark energy is winning. But in 2025, new measurements of dark energy's behavior hinted at something unexpected. The possibility that dark energy's strength is evolving, weakening over time. If dark energy fades, gravity could eventually reassert itself, and the collapse scenario returns to the table. Some models now suggest the universe could begin contracting in as little as a few billion years, ending in a crunch roughly 30 billion years from now. And there is a darker version of this scenario. If the universe crunches, the energy at the end may be sufficient to trigger a new Big Bang. A universe that dies by collapsing may be a universe that is reborn, which means this may have happened before, perhaps many times, perhaps an infinite number of times, and everything you have ever done has already happened, and will happen again, forever. Number 9. The false vacuum. The death that could come at any second, from anywhere, at the speed of light, with no warning, and we would never see it coming. Everything in physics seeks its lowest energy state. A ball rolls downhill, an electron falls to its lowest orbital. The question is whether the vacuum of space itself, the empty space between atoms, the nothing that fills the universe, is actually at its lowest possible energy. And the disturbing answer is that it might not be. Our vacuum may be a false vacuum, a state that appears stable but is actually perched on a ledge, like a ball resting in a small dip on the side of a much deeper valley. The mass of the Higgs boson, measured at the Large Hadron Collider, combined with the mass of the top quark, suggests that our vacuum sits uncomfortably close to the boundary between stable and metastable. The current best calculations say the universe's vacuum is metastable, not truly stable, just stuck. If a region of space ever tunnels into the true vacuum, through quantum fluctuation, or a high-energy event, or pure chance, a bubble of new physics forms. Inside that bubble, the laws of physics are different. The constants are different. Atoms as we know them cannot exist, and the bubble expands outward at the speed of light. Because it moves at light speed, no warning is possible. The first sign of the vacuum decay would be the event itself. The bubble's wall would pass through the Earth, through you and everything. Every atom, every structure, every thought, would cease to exist in the form it had an instant before, not destroyed, converted into a state of matter that follows different laws. The good news, if it can be called that, is that the probability of this happening in any given year is astronomically small. The unsettling news is that astronomically small is not zero, and that across an eternity, every possible quantum fluctuation eventually occurs. The vacuum may already have decayed somewhere. The bubble may already be coming. Number 8. Heat death of information. Even if matter survives, information itself has an expiration date. This death is quieter than the others, and in some ways more final. It comes from a discovery made by Jacob Bekenstein and Stephen Hawking in the 1970s that black holes have a temperature and slowly evaporate. But the deeper discovery was about information. Hawking showed that a black hole's radiation appears to be purely thermal, random, featureless, carrying no memory of what fell in. This creates a problem that physics has still not fully resolved. Quantum mechanics says information cannot be destroyed. Black hole evaporation seems to destroy it. Something has to give, and the leading resolutions all point the same unsettling direction. The universe's ability to store and preserve information is finite, and it decays. In the far future, after the stars burn out, after the black holes evaporate over 10 to the 100th power years, what remains is a thin soup of photons and elementary particles, each separated from the others by distances that grow forever. No particle will ever interact with another, and interaction is the only way information is created or transmitted. A universe without interaction is a universe in which no memory can form, no measurement can occur, and no record of anything can persist. The final state of such a universe is not just empty, it is unknowing. Nothing in it can contain a trace of what came before. Not the stars, not the galaxies, not us. The universe does not merely forget its history. It loses the physical capacity to have a history at all. Number 7. The slingshot of the Great Attractor. The death that may already have a direction. Everything falling towards something we cannot see. Our galaxy is not still. The Milky Way, along with thousands of neighboring galaxies, is moving through space at roughly 600 kilometers per second, pulled toward a region called the Great Attractor, a gravitational anomaly in the direction of the constellation Centaurus, hidden behind the plane of our own galaxy's dust. But the Great Attractor is not the end of the pull. Measurements of galaxy cluster motion across billions of light-years show a coherent flow, the dark flow, toward a point beyond even the Great Attractor, possibly beyond the edge of the observable universe itself. Something is pulling on our entire cosmic neighborhood, and whatever it is, we cannot see it, because the light from that region has not had time to reach us, or never will. The terrifying scenario embedded in this observation is simple. The universe's large-scale structure is not settled. It is flowing, converging, collapsing toward concentrations of mass, whose full extent we cannot measure. If the pull extends far enough and deep enough, the distant future of our region of the universe is not dispersal. It is convergence into a single, enormous gravitational collapse. Trillions of galaxies, falling into a structure so massive it would form the largest black hole-like object that could physically exist. We are falling right now. We have been falling for billions of years. And the most honest statement cosmology can make about what we are falling into is that it is big, it is dark, and it is coming. And the map of where it ends has a blank space exactly where the answer should be. Number 6. Proton decay, the slow disappearance of matter itself, every atom, quietly, one particle at a time. Protons are the hearts of every atomic nucleus. They are, as far as anyone has ever measured, stable. No proton has ever been observed to decay. But almost every theory that attempts to unify the forces of physics predicts that protons must eventually decay, on timescales far beyond the age of the universe. Experiments have been hunting for proton decay for decades. Giant underground detectors, tanks of ultra-pure water the size of buildings, watched by thousands of light sensors, have listened for the flash a dying proton would make. None has ever been seen. But the theories keep requiring it, and the experimental limits keep pushing the proton's lifetime estimate higher, currently beyond 10 to the 34th years, without ever ruling decay out. If protons decay, the timeline of the universe's death gains a new and eerie chapter. Around 10 to the 34th years from now, long after the last stars have died, matter itself begins to dissolve. Every planet, every stellar corpse, every object ever built by any civilization loses its atomic structure. Nuclei fall apart. What was once rock and metal and bone becomes a drizzle of radiation and light particles, drifting apart in the dark. By 10 to the 40th years, the universe contains no atoms at all, not one. The concept of an object, of a thing with structure and substance, ceases to apply anywhere. All that remains is black holes and a thinning mist of light in a universe that no longer contains the ingredients for anything to ever be built again. Number 5. The death of black holes. When the last structures in the universe evaporate, and nothing remains that can even hold gravity. In the far future, after the stars are gone and matter has dissolved, the only objects left in the universe will be black holes. They will be enormous, the merged remnants of galaxies and clusters, and they will seem eternal. They are not. Stephen Hawking's great discovery was that black holes are not perfectly black. Quantum effects at the event horizon cause them to emit a faint radiation, and with it, to lose mass. A stellar mass black hole will take roughly 10 to the 67th years to evaporate. The supermassive remnants at the centers of merged galaxies will take up to 10 to the 100th years, a 1 followed by 100 zeros, a number with no physical analogy, but they will evaporate. One by one, across timescales that make the current age of the universe look like a single Planck instant, the black holes will shrink, heat up, and finally vanish in a flash of radiation. And when the last one goes, something profound ends with it. Black holes are the universe's final structures, the last things with edges, with insides and outsides, with any organization at all. Their evaporation is the deletion of the last ordered objects in existence. After the final black hole dies, the universe contains only photons and light particles, cooling forever, never touching. And since mass is what curves time, since a universe of pure light experiences no passage of time at all, there is a real sense in which the death of the last black hole is the death of time itself. Number 4. The Big Bounce. The death that is not an ending, a universe that collapses and explodes again, forever, with no first beginning. The Big Bounce model proposes that the Big Bang was not the beginning, it was a bounce. The moment a previous universe, having collapsed, reached maximum density and rebounded into a new expansion. In this picture, our universe is one iteration in an infinite series. It was born from the death of the last one, and it will die to give birth to the next. The physics comes from loop quantum cosmology, a candidate theory of quantum gravity, in which space-time itself is made of discrete units and cannot be compressed below a minimum size. When a collapsing universe reaches that density, the theory says, gravity effectively becomes repulsive, and collapse reverses into expansion. The terrifying aspect of the bounce is not the physics, it is the implication. If the universe has bounced before, then there was no first moment, no creation, no point at which anything began. Every structure you have ever seen, every event in history, is one loop in an endless cycle with no origin and no purpose and no final state, just collapse and rebirth forever, in both directions of time, without limit. Some versions of the model carry an additional detail that deepens the unease. In each bounce, most information about the previous universe is destroyed, but some models suggest traces can survive. Remnant structures, gravitational anomalies, imprints. Which raises a question that cosmologists phrase carefully, and only in technical language. Whether anything in our sky, anything we have already cataloged as unexplained, is not from our universe at all, but from the one before. Number 3. Boltzmann Brains. In an eternal universe, the dominant form of consciousness is a single brain, appearing by chance, for a single moment, in an empty void. This one begins with a thermodynamic puzzle that has haunted physics since the 19th century. The universe is currently in a highly ordered state, low entropy, and that is strange because high entropy states are vastly more probable. Ludwig Boltzmann suggested a disturbing resolution. In an infinite or eternal universe, random fluctuations will occasionally produce pockets of order. Our universe, with its galaxies and history, might be one such fluctuation. But here's the problem. A fluctuation that produces an entire universe with a fake history and fake memories is enormously improbable. A fluctuation that produces a single brain with false memories of a universe, false sensations of a body, false experience of a life is vastly, incomparably more probable. It is easier for randomness to fake you than to fake everything. In an eternal universe, the numbers become horrifying. Given infinite time, Boltzmann brains, lone, momentary, spontaneously formed minds would outnumber real, evolved observers like us by an infinite factor. Statistically, in such a universe, the overwhelming majority of conscious experiences are Boltzmann brains. Which means that if the universe is eternal, the rational conclusion is that you are almost certainly one, a fluctuation, a moment, a mind with a fabricated past, about to dissolve back into the void. Physicists take this seriously enough that it has become a test. Any cosmological model that predicts more Boltzmann brains than real observers is considered ruled out, because it predicts that your observations should not be stable or coherent. And they are. For now, our models pass. But the argument stands as the strangest way the universe dies. Not in fire or ice, but in an eternity where the only things that ever exist are lonely, instant minds, hallucinating universes that never were. Number 2. The end of time itself. The scenario where time does not go on forever in an empty universe. It simply stops. This possibility emerged from a serious attempt to fix the Boltzmann brain problem. If an eternal universe produces infinite random minds and renders all prediction meaningless, then, some physicists argued, perhaps time is not eternal. Perhaps the correct conclusion is that the universe has a finite future, that time itself has an end. The idea takes several forms, but the sharpest version works like this. In certain models of the multiverse, probabilities only make sense if the total number of events is finite. For the mathematics of cosmology to function at all, time must terminate. The universe does not fade into endless emptiness. It reaches a final moment, a boundary, beyond which there is no after. Under this scenario, the end is not billions of trillions of years away. The calculations produced an estimate of 50% probability that time ends within roughly the next few billion years. Not because anything crashes or burns, but because the statistical architecture of reality requires an ending, the way a book requires a final page. What the end of time would look like from the inside is, by definition, indescribable. There would be no moment of realization, no final thought, no experience of anything stopping. The last instant would simply be the last. And the reason this scenario ranks so high on the list is that it is the only one in which the universe does not die slowly and observably. It ends the way a sentence ends, abruptly, completely, and without any warning in the text that came before. Number 1. The theory that the universe already died, the final possibility that we are not living in the universe's life, but in its afterglow. This is not a single theory, but a convergence of several, and it is the one that physicists discuss the most quietly. The evidence comes in pieces, each explainable on its own, together forming a shape nobody wants to name. The first piece is the arrow of time. The laws of physics work equally well forwards and backwards in time, every single one, except thermodynamics, which demands that disorder increases. The only reason time flows forward is that the universe began in an extraordinarily ordered state. Nobody knows why it did. The probability of such a low entropy beginning, calculated honestly, is so small that it strains the concept of probability itself. Roger Penrose computed the odds of our initial state as 1 in 10 to the power of 10 to the power of 123 dice, a number beyond all physical meaning. The second piece is the vacuum. Our vacuum is metastable, perched near instability, as though the universe's current state is a temporary residue of some other state that came before, a settling, not a foundation. The third piece is the cosmic microwave background, which contains anomalies. The cold spot, the alignments called the axis of evil, that some researchers have proposed are scars, imprints of events or structures from before the Big Bang, or from a collision with another universe fossilized in the oldest light we can see. Put together, the conjecture is this: what we call the universe, its expansion, its stars, its 14 billion years of history, may not be a beginning at all. It may be the long, luminous decay of something that already happened. The Big Bang as not a birth, but an aftermath. The ordered initial state, not a starting condition, but a dying ember of a prior reality. And everything since, every galaxy, every world, every mind, playing out inside the slow cooling of an event whose cause is permanently on the other side of a wall we cannot see through. In this picture, the universe is not going to die. It is dying. It has been dying since the first instant, and the whole of existence, all of history, all of us, is what its death looks like from the inside. If you want to see more videos like this, subscribe, like the video, and share with a loyal friend.